So here in example 3, we're going to roll a die again, but a fair die, and then we're going to toss a fair coin. So we're going to have 4 events defined here. So A is the event that we get 6 on the die and heads on the coin. B is even on the die, tails on the coin. C is just even on the die, whatever on the coin. D is tails on the coin, doesn't matter what the die was. So let's first list out our sample space. So we've got 6 possibilities for rolling the die here, and then 2 possibilities for the coin. So I'm using what's called an outcome table here. And I list the outcomes for the die on the left, 1 through 6, and then the outcomes for the coin across the top, heads, tails. And then it kind of works like a multiplication table. So 1 heads, 1 comma H. We could roll 1 and get tails, 1 comma T. And I'll put those in parentheses here as an ordered pair. We could roll 2 on the die and heads on the coin, 2 comma H. Or we could roll 2 on the heads, tails on the coin, 2 comma T. And then we keep going here. So we get 3 heads, 4 heads, 5 heads, 6 heads, 3 tails, 4 tails, 5 tails, 6 tails. So we've got 12 outcomes here, and they are equally likely because each choice here is equally likely and the same thing here. So these are equally likely. So that means we can use our shortcut in computing probabilities. So A, let's see, A is a 6 on the die and a heads on the coin. So if we get a 6 on the die and a heads on the coin, that's just this one outcome. That's A. So this is the probability of getting 6 heads. So, and actually an event is a set, so we probably should do the set containing the outcome 6 heads. And this is only one sample point. You've got 12 sample points that are equally likely. This is 1 out of 12. So desired outcomes, 1 sample point that we are desiring, and then 12 total sample points in the sample space and equally likely. Probability of B, so even on the die, tails on the coin. So even on the die, let me do this one in red. So even on the die, tails on the coin, that would be 2 tails, or 4 with the tails, or 6 with the tails. So that's the event B. And so the probability of B, well, we've got 1, 2, 3 sample points in B out of 12 sample points that are equally likely, so 3/12, 1/4, or 25%. Probability of the event C, even on the die. So we get even on the die. Let me do that in green. So we just want even on the die. So it could be 2 heads, 2 tails, or 4 heads, 4 tails, or 6 heads, 6 tails. So that's the event C, and we've got 1, 2, 3, 4, 5, 6 sample points out of 12 total that are equally likely, 6/12, 1/2. And then the event D, tails on the coin. Let's see here, I'll do that one in orange. So tails on the coin is just this column right here. That's event D. And that contains 6 outcomes out of a total of 12. So this is also 6 out of 12, not the same 6, but 1/2 probability there. So then again, here we're able to use desired out of total because they're equally likely outcomes. So these are equally likely.